Hello, everybody. I'm back again to talk about planning your science project experiment. So this is the second part, okay, the second video. In the first video, I talked about identifying the different variables, independent, dependent, and controlled variables. If you're unclear on what those are, make sure you go back and watch that earlier video. In this one, we're going to talk about data tables and also repeating your experiment, the importance of that. But let's start by talking about what data is.
Data refers to the observations and measurements that you are writing down during your experiment. Your hypothesis will either be supported or not supported by the data you collect, and you will write about this in your conclusion. Before you start your experiment, you should prepare to write down your observations. You need to make a data table, complete with boxes to write each measurement. The best way to organize your data table, in my opinion, is to start by writing each treatment along the top. What do I mean by treatments? Remember how your independent variable is what you are changing? Well, the different versions of your independent variable are your different treatments. For example, if your independent variable is the length of a hammer's handle, then you can put short, medium, and long at the top. Sometimes you will only have 2 treatments, sometimes you'll have more. In this case, I have 3. An experiment really shouldn't just have one treatment because that would mean that there is nothing to compare. Getting back to our data table, you need to make boxes below each of the treatments to record your measurements. Here we have the simplest data table possible, but we are not finished. If we were to fill out this table with one measurement for each treatment, we might be able to compare outcomes, but this comparison isn't going to mean much to a scientist. Your conclusion is going to be pretty weak. Why? Because we didn't collect enough data to really know if these numbers are accurate. You need to repeat your experiment to see if you'll keep getting measurements that are the same or close enough. So let's add some more boxes below where we can write additional measurements. For example, let's say I want to repeat this experiment one more time. Here I've made a second row for writing measurements. Because I have 3 different treatments, that means I would be measuring outcomes 6 times total. There's 6 boxes here. I still think this isn't really enough, so I'm going to add another row. 3 treatments, repeated 3 times, means I would be measuring outcomes 9 times total. Now, if you were a professional scientist, or if you were competing in a science fair, you would probably want to repeat your experiment 10 times or more. But for the purposes of this video, let's say 3 repetitions is enough. Now that your table has enough room for all of your data, you can conduct your experiment. Look, I'll show you what this table looks like filled in with data. The units I'm using are newtons, the metric unit of force. Make sure you include your units. Now notice how the numbers might be pretty close, but they aren't always the same. This is typical, but it does mean comparing the outcomes for different treatments might be tricky. That's why I like to make one last row in the data table. This is where you will write the average for each treatment. Now I don't want to spend too long talking about what an average is, but it's basically a way of turning a lot of data into a single number. You add up the measurements in a particular treatment, and then you divide by the number of measurements. And this average is a good representation of what sort of outcome you were observing for that treatment. You compare these averages when you are writing a conclusion. If you graph your results, most of the time you will want to graph the averages and not every single measurement. Now I want to pause here to make a quick note. The data table is for recording your dependent variable measurements. There might be other observations you want to record. For example, if something unexpected happened during the second trial, you'll want to write that down. If some other variable is also changing, not just your dependent variable, try to record this in a separate space. This extra information might help when you are writing about your conclusion. So let's review. Write the different treatments or versions of your independent variable along the top. Make rows for each trial, for each time you are repeating the experiment. Then make another row at the bottom to put the average for each treatment. This table will guide you through your experiment. Record other observations in a separate place, and use all of this information to conclude whether your hypothesis is supported or not supported. Let's do one more example. Let's say that our testable question is, how does the color of a flower affect the number of insects that come to visit it? The independent variable is the color of the flower. Let's say we are just trying out 2 different versions of the variable, 2 different colors, yellow and pink. You're going to write yellow and pink along the top. Next, how many times do we want to repeat this experiment? Let's say we are going to repeat it 5 times. Then we need 5 rows. Now we are ready to do the experiment. Here are some measurements. Notice the units are included in secs. Instead, you could write the units above. That way people know what the numbers represent, and this makes your table look a little bit nicer. Now, were we really expecting to have the same numbers every day? No, of course not. But all these different numbers make it hard to compare. So what do? We find the average for each treatment, for each color. Finally, we can graph the averages, but in this specific case, it might make sense to graph the changes over time as well.
All right, I think that's everything I wanted to say about setting up your data table and also repeating your experiment. The most important thing to remember is that properly setting up your data table is what's going to guide you through completing your experiment. And it's going to make it a lot easier to move on to the last chunk of the scientific method, which is your results and conclusion.